Lesson 1-2, algebraic expressions. Okay, so first we need to understand what the difference is between an expression and an equation. Okay, an expression is a collection of monomials, also known as terms. So is an equation. In an expression, they are attached with addition and subtraction, same as in an equation. However, an expression has no equal sign, an equation has an equal sign. And an expression cannot be solved, it can only be simplified, whereas an equation can be solved. Okay, first we need to know how to combine like terms. So if I had a basket and I had 3 apples and 2 oranges in one basket, and I had another basket and I had 5 apples and 6 oranges, how many would I have altogether? Well, I'd have 8 apples and 8 oranges. I would not have 16 orpals. This is why we have to add like terms. We can only add together the things that are similar to each other. We can't combine things that aren't alike. Apples and oranges do not combine to make orpals. So if we look at like terms, we have all these different terms here. In order to find the like terms, we need to find the ones that have the exact same variable portion. So if I take a 4y, I can only combine it with another y, 9y. If I take a 3 with no variable, I can only combine it with another number that has no variable, negative 16. If I have an x squared, I can only combine it with another term with an x squared, so 10x squared. And if I have an x with no squared, I can only combine it with another term that has an x with no squared. These are like terms. These can be combined. Anything that is not in the same box cannot be combined with each other. So I cannot combine 9y and 10x squared. I can only combine 4y and 9y. These are apples. These are oranges. So when we collect like terms, we first identify, then we can combine them or collect them. So we have integers, fractions, and decimals. Those are numbers that are standing alone. They're known as constants. Okay, constants can be combined with each other. Then we have the letters. They're called variables. They can represent any number and they can be any letter. We have numbers attached to letters, and there's 2 types. There's numbers in front of the letters, which are called coefficients. They get combined. And then we have exponents, which are attached to the back of the letter. So if we have this term here, the 3 is the coefficient, the 4 is the exponent, and the x is the variable. So when we collect them, first we identify the like terms. I have a 3x and a 7x. I have a negative 4y and an 8y. I have a 5 and a negative 10. I have a negative 2x squared and a 5x squared. And then I have this 8z that's just sort of by itself. It doesn't match anything. Then I can rearrange them so that all the like terms are together. But remember, I have to keep the signs with what they belong to. So this negative 2x squared, this negative stays with the 2. Here I have negative 2x squared and 5x. And then I did 3x and 7x, negative 4y and 8y, 5 and negative 10, and then this 8z that's sort of just by itself. Once I've rearranged them so that they're grouped together, then I can add the coefficients of the like terms, and then I can add the constants. So negative 2x squared plus 5x squared will give me positive 3x squared because negative 2 plus 5 is 3. 3x and 7x gives me 10x. Negative 4y and 8y. So negative 4y and 8y gives me 4y. 5 and negative 10 gives me, 8z. Gives me 8z, and then 5 and negative 10 gives me negative 5. So now I've combined them as much as I can. The x squared and the x don't match. They both have an x, but this one has a squared and this one doesn't, so they cannot go together. Y and z don't match. They can't go together. You can only combine the things that match perfectly. So here's some more examples. 5x and 3x match, so I put those next to each other. Then I combine them. 5x and 3x is 8x. Here I have the 7 and the 4 are already next to each other, so I combine them to make 11. The 3 and the 8 I rearrange, and then 3 and 8 combine to make 11. Here, already together, so I add them. Now on this particular problem I have variables with no coefficients. If there's no coefficient, there's an invisible 1 in front. So that's what you'll add. So when I rearrange this, I get the 3t and the t next to each other, and then the v and the 7v next to each other. 3t plus t is 4t's, 3 plus 1. v plus 7 is 8. 1 plus 7 is 8. 2v, 8 and 7 and t, I rearrange that to put the 8 and the 7 together. Those combine. The v and the t do not. They stay the same. Rearrange this. I put my y's together and my x's together. I combine my y's. I combine my x's. So I get 6y plus 12x plus 4. Rearranging this, I put my x out front. I've got my z's together. I've got my u's together. Those get combined. 2x plus 14z plus 7u. I rearrange, combine. 5x and 2x is 7x. 3y minus 8y is negative 5y, and then the 8 stands alone. We can multiply and divide monomials as well as adding and subtracting them, but only if they have what's called a common base. The base is this number. That's not the exponent, number or letter. We can also call them powers, and they represent repeated multiplication. So if I say 3 to the 4th, or 2 to the 6th, or 5 to the 3rd, 3 to the 4th is 3 being multiplied 4 times. 2 to the 6th is 2 being multiplied 6 times. It's not 2 times 6, it's actually 6 2's. So when we do multiplication, I'm going to add the exponents, and here's why. X to the 5th times x to the 8th. That is the same as saying 5x's being multiplied times 8x's being multiplied. And then I can count all those up, and there are 13x's. Well, that's kind of a pain to draw all that out. So I can use the rule. And I just add the exponents. So x to the 5th times x to the 8th is the same thing as x to the 5 plus 8, which gives me x to the 13th. X to the 4th times x squared is x to the 6th. If we have more than one variable or we have coefficients, we multiply the like parts. So if I have 3x squared y times 6x to the 3rd y squared, 3 and 6 get multiplied. X squared and x to the 3rd get multiplied, and y squared get multiplied. So when I multiply this out, I'm actually going to have 3 times 6, x squared times x to the 3rd, and y times y squared. 3 times 6 is 18. 2 plus 3 is 5. And if there's no exponent, there's a little invisible 1. So 1 plus 2 is 3. So let's do these. 2 times 3 is 6. There's a little invisible 1. 1 plus 2 is 3. 4 times 3 is 12. 2 plus 4 is 6. 2 times 6 is 12. This x squared here has nothing next to or in common, so I just carry it over. And then 1 plus 3 is 4. 5 times 6 is 30. 3 plus 2 is 5. 2 plus an invisible 1 is 3. Why don't you try these two? So go ahead and pause the video for a second and just try them, and then come back and check your answers. Okay, so check and see if you got that, and remember you added the exponents and multiplied the coefficients. Okay, next we want to talk about evaluating expressions. Remember we said that expressions could be simplified, not solved. So to evaluate expressions, we identify the values that have been given to us for the variables. We're not finding these values, they've been told to us. We replace the variables with that numerical value, and then we follow the order of operations to simplify. So I'm given x is 5, y is 3, z is negative 2. So I'm going to replace every x with a 5. Well, I have one x in here, so that gets replaced with a 5. Y is 3, and z is negative 2. Now, following the order of operations, I do exponents first, then I multiply, multiply again, then I add and subtract moving across. So I have 125 minus 18, that's 107, plus 8 is 115. Here, replace the x with a 5. Here's another x, so that's another 5. Okay, that's 30. Oops, I forgot my exponent. Negative 2 to the third is going to be negative 2 times negative 2 times negative 2. That's negative 8. So that's 4 times negative 8. 2 times 5 is 10 times 3 is 30. So I have 60. Sorry. 30 and 30, and then 4 times negative 8 is negative 32. 60 minus 32 is 28. Okay, here's some more. Okay, we have 4 more examples. We have x, y, z, a, b, and c. X is 2, y is negative 3, z is 5, and a is negative 4. I'm going to do that exponent first. Then I'm going to do multiplication. I have 5 times negative 3, that's negative 15, times negative 2, that's positive 30, and 3 times 2 is 6. 4 times 16 is 64, so I have 6 plus 30 plus 64. I add those together, and I get 100. 2x minus b squared, or 3 times x, so x is 2, b is 10, c is 1/2, y is negative 3, and x is 2. I have to do inside the parentheses first, so that's negative 8 squared. I can multiply these. Negative 3 times 2 is negative 6. I can take half of that, and I get negative 3. So I get 3 times 64 minus 3. So that's 192 minus 3. So that's 189. Okay, 2 more. I would like you to try these, and then you can pause the video, try them, and then check your answers. Okay, check your answers. Now, if you got to negative 150 over 800 on number 4, you're doing really well. We just had to reduce it, and so to reduce it, I ended up dividing them both by 50. And when I divide by 50, I get 3 over 16. The negative over a negative gives me a positive.